Hi, I'm Mr. Bastakodi, a student of MIT Australia, and today I'm going to demonstrate a packet tracer file that I did on behalf of BN321 assignment 2. Alright, so on the screen you can see two networks connected to each other with the help of a IPsec VPN tunnel, which basically ties up two routers with the help of a ISP router to help them communicate between each other. Alright, so on the left we can see branch Sydney R1, and on the right we can see branch Darwin R3. Alright, so Sydney R1 and R3 connected in the same pattern. I'll just describe a one network that is Sydney R1. Alright, so Sydney R1 connects the server switch of Sydney, which is server Sydney, and this server switch connects all the client switches, which connects the end devices that get the IP address through the DHCP server connected to the server Sydney switch, and also the server Sydney switch is connected to a access point for a wireless connection, which can be accessed by all the employees working in that company from anywhere wirelessly within the premises of the offices. Alright, so let's get on to how I did that IPsec VPN tunneling. Alright, so for that, I've got a list here. So first of all, what we need to do is we need to enable the security on the routers itself. So I'll just show you how I did that. So here, if you can see, so first of all, this is the security that I enabled. In order to do that, you need to paste a command, which will be like that, and it will enable the security. If you press yes, and then the security is enabled. So if you do show version, sorry, I need to exit from here, and then show version, it will be illustrated that the security has been enabled. So afterwards, there are all the other steps that we need to do. So first of all, the first step is creating an access list. All right, so here is my access list. Permit 100 for IP from which will permit the network from the left hand side to the right hand side, which is 1.0 to 3.0, and vice versa. We will change this to 3.0 and 1.0 from network 3 to network 1. Also, I have done all the configurations needed for the routers to connect to each other in this IPsec tunnel. So these are all the configurations with IP route facing towards the ISP router for both the routers, which is that one and that one, that one and that one. All right, so and then afterwards, in the second step, what we need to do is create a IPsec ISACAM policy. To do that, crypto ISACAM policy number 10, encryption AES 256, and authentication will be a preset phase, and Diffie-Hellman group 5. That is the second step. And for the phase 2 of the ISACAM policy, we will be setting a ISACAM key, which will be security key itself in my case. So to do that, crypto ISACAM key, and what is the key itself? So for my case, it is secret key, and address of the opposite router. So it will be that one, opposite router. And on the router R3, we'll do the 100.1 for the opposite of that router. All right, and then afterwards we're going to set up a transform set. So transform set, to set up a transform set, what we need to do is crypto IPsec transform set from router R1 to R3. This is just the name, which we'll be using in later commands, and ESP AES encryption 256 with ESP SAR HashMac a key hash. All right, and then afterwards, to set up a crypto map, which is essential for IPsec VPN tunnel in order to communicate from R1 to Darwin R3, crypto map, which we gave the name we gave, that is IPsec map, number 10, IPsec ISACAM, and setting the peer for the next router on the opposite side would be 200.1, and setting a perfect forward secrecy group number 5, Diffie-Hellman group number 5, and then setting the security association lifetime, that is for 86,400, that is just for a day, and then seconds, and set the transform set from R1 to R3 in the case of R1, and matching address 100, which is the access list that we did here, access list 100. And so this will be done in router R1 and will be done in router R3 by just changing these two elements, R3 to R2, and then this will be 100.1 for default routers, as we discussed. All right, so afterwards all the settings are done till here. So we set up access list, we set up ISACAM policy, we did IPsec transform set, and we did crypto map as well, and we tied it all together. So now all we need to do is we need to apply that crypto map to the gigabit Ethernet 0.0. All right, so to do that what we need to do is we need to get into interface gigabit Ethernet 0/0 on both the routers and copy and paste this command. Why? This is just a crypto map, and the name that we get, IPsec map, is the name that we get, and that I get is IPsec map, which we gave it over here, and it will enable the command, and it will enable the command, enable the tunnel itself. So that's how I set up my IPsec VPN tunnels. So just to make it clear, let's try to ping between these two networks from here to there. It will be failing for the first time, but it will be successful afterwards. Just in case for the clarity, I'm just gonna do it from command prompt as well. So let's see the network. So that is 3.5 from that PC. So ping 192.160.3.5. You can see the replies. All right, so that's it from my side, and I will pass it on to my other teammate for further discussion on other topics. Thank you.
Hello, my name is Tawang Dendok with student ID MIT 182692, and today I'll be demonstrating the VLANs that we have created in our network design for BN321 assignment to group work. As you can see that we have the network design, and as per the case study, we have two sites, Sydney site with 7 departments and Darwin site with 5 departments. So in order to configure the VLANs for each department, we have configured the server switch as VTP server in order to create all the VLANs that can be accessed by these individual switches for each department, which are configured as VTP client. Similarly, the same process we have done for Darwin site, in which this the server's VTP server, it has been created for the main switch, and these switches in respective departments are configured as VTP client. So I'll quickly show the main VTP server in Sydney. Sorry about that. Status. As you can see, this main server switch has been configured as VTP server, and the domain name is Sydney. So I'll show you the VLANs that we have created for Sydney for each department. As you can see, we have 7 departments: reception, finance, IT, marketing, manager, human resource, and public relations. So we have created 7 VLANs for each department. And this each department has each switches which has been configured as VTP client mode, and that means that they can access VLANs respective to their departments from the main VTP server. So I'll quickly show the status of the reception department VTP client switch. As you can see, this the switch is configured as a client switch, and also the VLANs of the respective department, in which VLAN 10 is for reception, and all these ports are configured. So that means that any devices connected in this department through these ports are connected to the VLAN of the reception department. Similarly, all of the all other switches are configured to their respective VLANs in the Sydney site, and all of the department switches which are configured as client mode in Darwin are configured so that they can access their respective VLANs. And for the last thing, I'll just show you the successful pinging that happens between the VLANs for each department. As you can see, PC reception in PC and Sydney site is able to ping with the IT department in the Darwin site. So it means that these VLANs in each site, they're successful, and they're successful pinging, and they're successfully communicating to each other. Thank you.
Discussing about wireless access points and DHCP server. And as we go here, DHCP server. For DHCP server, we have to assign the IP address manually. So the IP address is 192.168.1.2. This is the subnet mask, and that's the default gateway 192.168.1.1. After assigning IP address to the server, we go to services and DHCP, and we turn it on. We haven't reserved any IP address for this network, so we will leave it as it is, and we will go there, and now we will check if it is assigning the IP address or not. Yes, the IP address is successful. We go desktop IP configuration. Now we will check it for the wireless access points. Desktop IP configuration static DHCP. There you go. The request is successful for the Sydney network, and now we will check for the Darwin network. So first thing first, you need to go and assign the IP address to the DHCP server. There you go, subnet mask, and we'll give 192.160.3.1. That's the default gateway. Now we go to services, DHCP, turn it on. We haven't reserved any IP address for this one as well. We go desktop IP configuration, DHCP. Yep, this is successful. Now we go and check the wireless access points IP configuration, DHCP. There you go. This is successful. Configuration, DHCP. There you go. Thank you.
Okay, hello. My name's Michael. This is BN321 Assignment 1, Group 2. I'll be demonstrating our network diagram. So I'll be talking about the protocol that we've used, which is OSPF, or Open Shortest Path First. So as per the case study requirements, we've obviously got a Sydney and a Darwin network. So in order for the routers to exchange information or whatnot, we'll be using a protocol, which is obviously OSPF. Again, what that will allow us to do is to, like I was saying, exchange information between the different routers. So for example, if I ping from Sydney to Darwin, you can see here it's successful. So we've got our third router here, which is our ISP router. And then if I show the running config, you'll be able to see it's offshore. You'll be able to see, sorry, that we're running the OSPF command. So let me just enable it. Run. And then you can see here, OSPF, we've got the network, and then we've put our IP addresses and then the area 0. So again, that allows us to communicate with Sydney and Darwin. And one last thing I'll show is a ping between Sydney. So this is one of the VLANs to another one. And again, you can see it's successful. So everything is successfully pinging. I'll now pass it over to one of my other team members.